What's up? What's up? What's up? You are now tuned in to the network. And today's topic is Section 3.3, Configure and Verify Static Routing. That's right, we finally wrapped up IPv6. This is a topic in the CCNP ROUTE Exam, exam code 300-101, version 2.0. Let's take a look at the exam blueprint, see where we came from and where we are headed. All right, so this is the exam blueprint implementing Cisco IP routing. Again, this exam code 300-101. You already know, sign up for the correct exam. Make sure it's the right version. Even though CCNP hasn't updated in a while, just make sure it is the correct version. Or you're studying for the correct version, rather. So we just wrapped up the whole IPv6 section. That's right, we are finally done with that. We're not done completely, just the identifying, addressing, and subnetting portion. Today we are going to be doing configuring and verifying static routing, which I'm pretty sure you're familiar with, but we're just going to go over some of the little nuances and do a simple examples on, yes, my favorite, packet tracer. And then after that, we gonna go over configuring and verify default routing. Now they kind of go hand in hand, but like I said, for these videos I'm doing separate videos for every topic. So static routing, let's talk about, before I talk about what static routing is, let's talk about the difference between static routing and the I guess the opposite to that, or the I guess the opposite of that, which would be dynamic routing. So let's talk about the word static and dynamic, right? So static means it's always the same. That's basically it. It's always the same thing, right? Like me, I always do the same thing. I have a routine. I'm always, doing my laundry the same. I do the dishes the same. I eat the same foods. I'm just a static person. I guess you could say that. Also, dynamic routing. Dynamic routing is obviously always changing. For example, my girlfriend's mood. She might be happy one day and then just mean the next. So she would be considered the dynamic person. She likes trying different foods. She's always doing something different. So she would be the dynamic routing part. I am the static routing. So basically, static routing is always the same. It's the same route to go somewhere all the freaking time. Like my mom, she used to take the same road to work all the time. She don't take different ways. I always, not always, but I try to find different ways if it is another way that's quicker or whatever. A dynamic route is something that would change all the time. And the ways that happen is done through different routing protocols such as BGP, EIGRP, RIP. There's a couple more out there. Some are outdated and deprecated, 6 feet under, but RIP, get it? I'll be coming up with these corny jokes. But anyways, so yeah, that's static routing versus dynamic routing, right? We're going to go over the dynamic routing. Trust me, we will go over further in detail with the dynamic routes in the other sections. Let's head over to the slides and take a look at the official definition. Actually, this is another corny imagery that I came up with. Static on the left-hand side and on the right-hand side, a route to somewhere. Corny stuff again, you know me. That is not a static route. This right here, these two images are not a static route. It's a static route if you look at it technically, in the literal sense, but this is not a static route. The static route is defined as a form of routing that occurs when a router uses a manually configured routing entry rather than information from a dynamic routing traffic. I think that was wrong. And this is why I should not be trusting Wikipedia. But luckily I proofread my stuff. This should say rather than information from a dynamic routing protocol. That's what I think it should say. But, as you know, Wikipedia anybody can edit it. It is a really trustworthy source, but make sure you are looking it over. In many cases, static routes, yes, I know, I still like Wikipedia, are manually configured by a network administrator by adding entries into a routing table, though this may not always be the case. Unlike dynamic routing, my girlfriend, static routes are fixed and do not change if the network is changed or reconfigured. So there's pros and cons to both of them. I'm not going to lay down all the pros and cons, but for one thing, we can talk about static routes. It's it's a reliable route, and you know it's one that you configured. Or maybe the last guy that got fired or left the job, he might have configured it, but you know it was manually entered. However, if the interface that this route is pointing to goes down, your route you may still be routing to that, that route, or you might still be pointing your traffic through that route, and that's not good. So that's where a dynamic routing protocol may come in handy. If one route goes down, then you could have a backup route, or you could have, it'll just change because of, like I said, it's dynamic. That's why they designed them that way. However, there is a way that we could kind of fix the static route and have kind of like a backup. We'll talk about all that later on in these slides. All right, so the way you configure a static route is real simple. These two keywords, you go to the interface, you go to configuration mode of the router, and you just type in IP route. And I'm going to show you the exact command or syntax. You will put the destination of where you're trying to go. So you do IP route, destination you're trying to go, the subnet mask of the location you're trying to go, and then what's the next hop, the address of the next hop router, or the address of the forwarding router's address. As you can see here, static routes, it says here, are commonly used when routing from a network to a stub network. From a network to a stub network. You may ask, what's a stub network? If you're a fast reader, you already done read these bullet points. As you can see, a stub network is where it's just one way in to one way to get to that location. And that's where a static route will come in. Ain't no other way to get there. You just type in you just manually type it in, your configuration, and that tells the router to send all the traffic to that location. If you're from the Orlando area, I don't know, there might be some cities of where you're from. There's that one little town that got one way to get in there and one way out, right? Over here in the Central Florida area, we have what's called a little subset city called Poinciana. That's part of Kissimmee. It's only like one way. They just built the road to get to I-4 to get there, but really it's only one way to get into that city and one way out. And boy, and in rush hour, the traffic is just so much traffic, and they only got like 2-lane roads on both sides. That city would be considered a stub city, if you will. But it's really, that would be the stub network when we're talking about networks. It's only one way in, one way out. So that's where the static route would come in, or come in handy rather. As you can see here, stub network is a network accessed by a single route. Has only one way to get there, via router 2. As you can see in this topology right here, this network is the 3.0 network. We got the 3.0 network and the 2.0 network. It's only one way to get to the 3.0 network, so you just create a static route. I'll show you the syntax in a bit. Dynamic protocol. Okay, so therefore, router 1 is a stub router. So that's a stub router. This would be the stub network. There's only one way in, one way out. A dynamic protocol between router 1 and router 2, if you put one between these two routers right here, it would be a waste of resources. So you sitting here trying to configure EIGRP, some other routing protocol that could use up, resources on, like OSPF, for example, uses a lot of resources on your CPU sometimes. Most of the time, if you have a lot of routes or a lot of changes to your network, OSPF, which is the dynamic routing protocol, it would just be a waste of resource where you could have just typed in one command to get to that stub network, and that's where static route will come in. So this is the syntax right here. Simple. Again, you go to the configuration mode, IP route, and then the prefix mask, or in this case, the destination of the network you're trying to get to, and then these are other options that you can put in. But the ones we really concerned with are the prefix mask, and then the prefix, the prefix, the mask, and then it could be, you could do the exit interface, or you put in the next hop router. I'll show you the difference in the next couple of slides on why you would want to do either the interface or the next hop router or the forwarding router's address. I believe we'll go more into that in the next video. As a matter of fact, next video, we're going to be going over a little bit of more static routing as well as introducing default routing, which default routing is a type of static routing. We'll go more into that in the next video again. Okay, so again, here's a simpler version of the syntax, which was what I was explaining to y'all. You go to config mode, IP, route, the network address, subnet mask of the network you're trying to get to, the IP address of the IP address of the next hop router, and then or you could put the exit interface, meaning of your local router. So you could be like saying, to get to Tampa, you could take I-4. Again, this is central route, Central Florida roads. Wherever city you from, you could kind of, compare that or make your own analogy. These are the stuff, these are the stuff I do to try to remember how to remember these syntaxes. So to get to one city, you take this road, basically is what you're saying with this command right here. So the following parameters are used: network address, the place you're trying to get to, subnet mask of the place you're trying to get to, and then one or both of the parameters must also be used. The IP address, which I've been saying the whole time, next hop router's IP address, starting to sound like a broken record, or the exit interface. Now this is the special caveat to this: the outgoing interface that will be used in forwarding packets to the destination network, equivalent to the interface type, interface number, parameter, and the complete syntax. So you could do, instead of the next hop router, you could just say, take serial interface or gigabit interface 00 of this router, out of this router, to get to that location. I'll give you an example. I believe in the next video. Probably will do it in this one too. I don't want to make too many false promises. Okay, so again, here's another breakdown, another example of the syntax: IP, route, address of the place, the subnet mask trying to get to, and then the forwarding router's IP address. Notice how it says it's commonly referred to as the next hop, which I've been saying this whole time. Router's IP address. I used to make a mistake back when I was studying for CCNA and stuff, thinking you put the IP address of your exit interface. That's not what you do. You just think about the other router and the other destination. Where your router will come in is if you need to do the exit interface, not the IP address, but the actual interface, whether it's a gigabit or fast Ethernet or serial, whatever. And as you can see, it says here, however, the IP address parameter could be any IP address as long as it's resolvable in the routing table. This is beyond the scope of this course. That's probably a CCIE topic. That's probably why it says that there. Configuring static routes. So, you could debug IP routing. I haven't really done a debug of static routes and stuff. But when you do, this is how you verify it. You just do show IP route. There's also, show running config. So you do a show running config, and it shows all your static routes that you have in there. So again, you can see right here, IP route, to get to this network and this network's subnet mask, take this next hop. That's basically what that's saying. Same thing here. To get to this network and this network's subnet mask, take this next hop. They all saying the same thing, kind of. Well, not all saying the same thing. These are the different destination networks. But notice they all have the same next hop, right? These guys right here. So when you do a show IP route, you'll see, you know how you got codes at the top. I'll show y'all an example when we launch Packet Tracer. I know Packet Tracer is a CCNA tool, but I like explaining things on Packet Tracer. Okay, I do have some live hardware if y'all want to see. This is my little rack. I may do a whole video on my whole rack, but for these videos, I want to explain them in Packet Tracer. All right. Okay. So over here, you can see in the red, static route will be labeled with an S right there. That's the code for it. You'll see an S beside it. You'll see a star if it's a default route. Next video, we'll go over default routes. And it's basically saying to get to this network, these two numbers right here is the AD and the metric. We'll go over that in the next couple slides. This is the administrative distance, and that's the metric. To get to this route, take this next hop router. I wish I had a topology to explain this. I think there is. In our chapter topology, blah, blah, blah. I just didn't get it. The remote networks, as you can see right here, the LAN on router 2. That's that topology. I should have put them in there together. So anyways, yeah, this is basically the routing table for this guy right here. If you want to pause it, whatever, or, you know, send me a message and I can email you these slides or whatever. Okay, this is how you configure static route. Again, we've already done this. I'm gonna go ahead and skip this slide right here. This is a breakdown, actually. IP route, that's the command. Network address of the remote network, subnet mask of the remote network, and then this is the next hop of that network to get to that network. 00000 interface of IP of router 2, which is the next hop to this network. When the IP address is the actual next hop router's IP address, this address is reachable from one of the router's directly connected networks. So you could reach a route that's not directly connected to you by creating a static route. That's where a default route will help you come in, or will help come in. But if it's directly attached, then you could just put the serial interface, or you could just put like the actual interface. You don't have to put the IP address. This is configuring routes to 2 or more networks. You just basically type in one, you know, each command. So, and if you notice here, you would think, like, you look at these routing tables. I used to get confused with sometimes with these little numbers in here. Like the 1 right here is an administrative distance, right? So for a static route, the administrative distance is always 1. Because it's static, it's always 1. So that's a pretty good administrative distance. Remember, the administrative distance is like the trustworthiness of a route. The lower, you would think the higher, but really, yeah, the lower the administrative distance, or sometimes they call it AD, the more trustworthy it is. The metric is kind of like the distance in a way, if you want to, you know, compare it to like roads and stuff like that. A lot of networking, you know, terminology, you can compare it to, you know, roads on the highway, or, you know, just roads, local roads, just roads in general, or how to get somewhere. That's why they call it routing. You just got mine effed right there, didn't you? Anyways, again, we verify with show running config or show IP route. Make sure you save. That's what that is. Again, this is the definition for administrative distance and metric. The official definitions, rather. If the router has more than one route found by 2 different routing protocols for the same destination network, a router chooses the administrative distance to choose the best one. So if you got a route if you got a dynamic routing protocol, which you would think is better, like say EIGRP, we know the administrative distance is 90 for EIGRP, or OSPF it's 110. But a static route is, the administrative distance is 1. So it's gonna always pick the static route if you put it in there, and that they put it lower because it's something you know is probably the best route and is reliable, whatever. So you put it in there. That's why a static route is lower. It's more trustworthy than a dynamic route. Dynamic route is changing, but in some cases there will be 2 paths by the same protocol to the same destination network. That's where a routing protocol will use the metric to find the best path. And the metric for a static route is always 0. And the metric for dynamic routes, they could change. Again, dynamic always changes. Static is always the same. Let's go ahead and run a simple example of a static route. Okay, real simple topology I created. Before we go into it, let's just explain what we got working with here. Over here on the left-hand side, we got the blue network. On the right-hand side, we got the green network. I sound like a referee. The blue network is the 192.168.0.0. Green is the 10.0.0.0 network, right? We only got 2 steps here. We just need to create 2 static routes. It's simple. We're going to create static routes that will connect both of these networks, really, and vice versa. You can't just have a static route going one way and that's it. The other way, the other router needs to have a route coming back. So if you're pinging something from one end, you have to have a route coming back. You know, back when I was first studying for this stuff, I'm like, why is this not working? Oh, it got to have a way back. When you pinging, because remember, a ping is it's like a sonar. It's like a radar. You send something and then you, boom, that's why they call it ping. And a little known fact, the reply is called a pong. Ping pong. Bet y'all didn't know that either. Anyway, so you respecting the reply, right? The reply you have to have a route back. So you have to create a static route heading somewhere and coming back. You could have either static or dynamic, but today we're covering static routes, right? So that's why we only need to create 2 static routes. So we need to create one from the blue to the green, right? We got and then let's not forget, this is another network essentially. This point-to-point network right here. It's a class B. It's 152.72.21 network, right? Let's go ahead and to this router and configure the routes. Okay, so we go to enable. I'll give y'all a pop quiz. How do you configure a static route? We need to configure a static route from router 1 to router 2. And we need these PCs to ping those PCs over there, right? So take a look at this topology and think about what the route should be from router 1 to router 2. All right, we back. You should have hit pause. Go ahead and configure terminal, right? IP route. Look at that. I had the dog even give me the answer. So y'all should have known this one. All right, to get to this route, right, or to this network, we trying to get to the 10.0.0 network, right? 10.0.0.0 network. And then the subnet mask is 255.0.0.0. To get there, we need to take the next hop router, which is this guy. See, we ain't even have to look at the configuration on the next router because they're labeled on here. That's why this is a little too easy for y'all, for me at least. We've got all the network addressing up here. We didn't have to discover the network, look at the interfaces, or that's because I already pre-created the interfaces and the IP addresses and stuff like that. But again, this is because I wanted to explain it. It makes it easy, really easy to explain. 255.0 network, we have to take the next hop router's IP address, which is 150.72.21.2, right? Notice we halfway done so far. So now we got a route. Before we even try, let me show y'all something. Okay, so we created a route going this way. Can one of these PCs ping one of these guys? Let's go ahead and take a look. Ping 190. I'm sorry. We need to ping one of these guys right here. 10.25.15.2. Pinging, pinging, pinging. Timeout. Timeout. I'm not going to let it ping all the way, but basically it's going to fail. You know why? Pause it and think about it. We back. We don't have a route back. So we have a route to this network, but we don't have a route back. It's going to be getting them pings. I should do a debug so that way we can see the pings, like debug IP pings. That way we can see them. It's getting there. They just not coming back. It's kind of like it's going to a black hole, really. So let's go ahead and create a route back. Go ahead and take a look at this topology and tell me what you think the command is to configure a static route. We are back. Again, you go to configure terminal, the configuration mode. We need a route to get to this network, right? The blue network. IP route is the command, right? The destination network, 192.168.0.0. The subnet mask of the destination network, 255.255.255.0. And then the next hop or forwarding router's IP address. In this case, it's that guy right there. So to get to this network, we need to go to that interface. Nothing on your router. You could do the exit interface, but I don't think that's what we're looking for right now. We look for the next hop router. So 255, I'm sorry, 150.72.21.1. What did I do wrong here? IP route. Did I do it on the right? Yeah, that should be it. Maybe I just didn't put the grading on there right. But let's go ahead and see if we can ping the other side. Pinging, yeah, we got a reply. I guess I must have done the grading wrong. Let's go ahead and take a look at our routing table on this guy. I guess I didn't show y'all at the beginning, the first time, the routing table when it doesn't have the route. But anyways, we verify with show IP route. Notice what it says to get to the 10.0 network. Our administrative distance is 1. Right, because it's a static route. Static routes, the AD is 1. The metric is 0. It's always 0. Via. So basically, you saying with this command right here, leave it on top for y'all. To get to this network, which is that guy, go to this forwarding router's interface. This guy right here. Right. So to get there, we got to go here. That makes sense? Really simple command. Let's go ahead and move on to the next portion of static routes. Let me figure out why. Oh no, I gotta fix that part. I gotta fix the grading on this. Okay, so another flavor or another type of static route is a floating static route. This is, as you can see right here, you got a little floaty right here. This is kind of like a backup route for static routes. Because remember, if an interface goes down and you have a static route pointing that way, it's going to keep sending your traffic that way, even though the interface is down. So this is where a static route can come in. You know, you ain't got to worry about this with a dynamic routing protocol if you got more than one routes or more than one interface. Because if one route is down, you have another. The dynamic route is going to change your route. Basically, it's kind of like a detour. Or, you know, it's kind of like, you know, those flagsmen with construction telling people, okay, you got to go this way because this exit is closed kind of thing. Remember, I told you we can compare networking with roads and traffic and stuff like that, real life traffic. So the floating static route will be like the backup route. One route goes down, we throw this. That's why they call it a floating static route, because this is kind of like a in case of emergency break glass type of thing. You know, it's like we got an emergency. We need an emergency. We need a backup way to get there. And I'll show you a real simple example of a floating static route. Here's the official definition. A floating static route is a static route that has an AD, or administrative distance, manually configured to be higher than the AD of a routing protocol in use. So remember, the AD for a static route is, again, what? Pause and think about it. We said it a million times in this video so far. It's 1, right? But if that route goes down, if you have a static route that has if you entered another static route that has a higher administrative distance, that's going to be put in your routing table. Well, it's not going to show up in your routing table. I'll take that back. It's not going to show up in your routing table, but it's going to show up in your running config. If that route goes down, then it's going to be kind of like, okay, this is the next one that's best that we can go to, because the administrative distance on this is higher, but you know, it'll take it that way because that's basically the next one in line, really. It will probably take dynamic routes first, because the dynamic routes are like in the mid. It depends on what you set your AD as, and I'll show you an example. This is done so the route is not used unless the routing protocol loses the route. So that's why we want to try to set the AD pretty high, you know, somewhere. And I'll show you the AD chart. Let me show y'all an AD chart real quick. So this right here, shout out to, I believe this guy is a dude that's studying for his CCIE. I'm not sure. But anyways, or was probably. This is the administrative distances, right? It's good to notice static route is 1. And, you know, everything else is, if you notice, look at the range, right? 0 to 255. You probably want your routes somewhere, your backup route somewhere in here, you know, between 200 and 255. Let's go ahead and head over to Packet Tracer so I can show y'all an example. Okay, so first thing we're gonna do, we talked about what a floating static route is, right? We gonna configure a static route. First thing we're gonna do is configure a static route, and then actually we believe we're gonna be creating a default route. No. Yeah, we're gonna be creating a default route. So a default route, again, we'll go over more in detail on what a default route is in the next video, because that's the next section. But basically, a default route is basically if you're saying, I ain't got no way to get there, let's just go this way, because this is the way we know. So like if you in your city, you trying to get to, let's say you in New York, and you don't know the way to get to California driving, right? You just know how to pretty much get out of your neighborhood. You like, I don't know how to get there. Let's just take this way. That would be your default route, if that makes any sense. So that's a good analogy. Now that I think about it, we're gonna go further into that in the next video, though. So the way you would do that is just creating all zeros, because and sometimes they call it a quad zero route, or yeah, quad zero route or a zero route. We'll go ahead and configure that. So notice here we've got two local area networks. We got local area 1, local area 2. We got our edge router here. We got two ISPs right here. Then we have the internet right here and the web server. So we got these two local area networks that's trying to get to this web server on the internet, right? First thing we need to do is configure a directly attached static default route from the edge router to the internet. The primary default route should be through ISP1. So notice, to get to the internet, we got two ways to get there, ISP1, ISP2. For this task, we need to create a route to get to ISP1. First thing we need to do is figure out what this interface is, right? I made the font a little bigger so y'all can see. I didn't even think about that until now. Let's enable. Let's do a no IP domain, just in case I get caught up with those. I hate that. No, I think I go to a configuration mode for that. Configure terminal, no IP domain dash name lookup. Right, and then let's do a show CDP neighbors detail, so we can see we got LAN 1, we got who else we got as a neighbor? We got LAN 2. That's not what we're looking for. We got ISP2, right? And then we also got, let's see, where's ISP1 is what we was looking for. There go ISP1, and that's his IP address. So we need a route to get to that address right there. 1010.1, right? Let's also take a look at our interfaces here. Show IP interface brief. We said 1010.1, right? So then that must be, this is most likely a /6 /30 interface. So that's most likely the exit interface. Let's verify that with a show. Let's do a show interface serial 000. And yeah, it's a /30. So that means we know there's only going to be two usable IP addresses. The other one will be .1, right? So that's the interface we need to exit out of, right? Serial 000, right? So let's do our IP route. We didn't even need to do all of that, but I was just showing y'all. This is the default route, right? 000, quad 0. The subnet mask is also 0 for your default route, right? Now we're gonna create. We need the IP address of the next hop router, right? In this case, which was ISP1, and ISP1 is 1010.1, right? That's our next hop router. So 10.10.10.1, and then the next thing we need to do here is we put our AD. Now I should have showed y'all. Let's say before we do this, let's take a look at the let's take a look at our routing table. See what we're working with, right? Let's just do that as a mistake. Do show IP route. Notice we have routes to get to all of these guys, right? Gateway of last resort is not set. So let's go ahead and create. We got a way to get to, yeah, see, it's directly attached, right? But we don't have a static route for it. It's just that it's directly attached. Anyway, let's do this. Go ahead and put in, let's paste that bad boy, right? That's the, this is the static route, right? But you want to put the administrative distance at the end. And you want it to be higher than these guys, right? What are the administrative distance on these guys? This is directly attached. These are actually all true. These are the AD on these guys should be 0 because they're directly attached to us, right? Let's do 200 is what it said, I believe. No, we're not doing the AD yet. We're not doing the AD yet. We're just gonna do the static route to that location, right? So that's our static route. Let's take a look at the IP table now. IP route. Notice now we have our static route, right? We didn't have one at first up here, right? We got local connected, local connected. Here's the codes. The one we concerned with is, notice here, remember we had gateway of last resort was not set, right? That's basically like your last resort. Like, I don't know how to get there. Let's just send our traffic that way. That's basically your the route out of your neighborhood to get to some remote city. You know, Timbuktu or something. You're saying to the gateway of last resort is this next top router to that. That's like to I don't know where. Basically, you're saying just send. You don't know how to get there. Just send them out this interface. And this is the route in the routing table, right? The star basically means it's a candidate default, right? And then the S obviously means it's a static route, 000. This is subnet mask. This is the AD, right? Administrative distance is 1. Metric is 0. To go to this location, to that's like the land of nowhere. Not necessarily the land of nowhere, but we don't know how to get there. We don't know the city. We want to get out of this neighborhood. Take this route. That's basically what that's saying. Right? Next thing they want us to do is so we displayed the routing table, verify that it's in the routing table. What command is used to trace a path from the PC to a destination? You know what that is? Trace route. Let's trace a route from PC A to the web server, right? PC A, trace RT. Web server is 198.0.0.10. It's tracing the route, so it took 10.1, right, which is their default gateway. 10.1, which is that guy, is ISP1. And then it got the next hop would be the web server, right? And that's the route it took. So basically it went from PCA, LAN 1, edge router, ISP1, internet to the web server, right? What's the, now we're going to configure a floating static route, right? That was the static route that we created. We did all zeros. That's called a default route. We'll go further into that in the next video. Configure a floating static route. This is what we just covered, right? Or talked about, rather. What is the AD of a static route? Pause it and think about it. We've said it a million times. This is probably like the 5th time we said this already. The AD is 1 for a static route. Configure a directly attached floating static default route with an AD of 5. Notice that's going to be higher than 1, obviously. So that means it's going to be if the 0 route is down, or the route with the AD that's 1 rather is down, then we're going to use this backup route. That's why it's called a floating. I think that's why they call it floating static route, because it's like throwing a floaty to save somebody because they they have an emergency. The route should point to ISP2. So the way we're going to do that is go back to the edge router. We said our ISP2 was, let's do show CDP neighbor detail. ISP2 was, that's LAN 1, right? LAN 2. ISP2, that's the IP address for ISP2. I'm going to copy that guy, right? And then let's go to configure terminal so we can create our static route. But they want us to point it to ISP2, and it has to be a default route pointing to ISP2, but it has to be a floating one. The floating one, basically, you just adding the AD to the route, to the static route. So in this case, IP route, right? We know that's how to configure a static route. Quad 0, subnet mask is also quad 0. The next hop router is our ISP2, which we just discovered, 1010.5. And then you, at the end, I'm going to put a question mark so y'all can see the distance metric for this route. They want us to configure it to be 5, right? So now let's take a look at our routing table before we do anything, right? View the, well, let's see. So the first here it says, view the running configuration and verify that the floating static route is there as well as the static route. So we do show run, right? And there's our static route, right? And this is the floating static route, right? Because the only difference here is, yes, it's a different router, but it's floating because of the AD there. So we always going to be using this first. Why? Because the static route's AD is what? Damn it, we said it about 8 times already. It is 1. The floating static route, we've manually configured it to be 5, right? Okay. Display the contents of the routing table. Now they want us to show IP route. What do they want to know here? Is the floating static route visible in the routing table? Why or why not? Why not? What do we say our floating static route is? Right? Quad 0. Take ISP2, right? Which was 1010.5. We still have our regular one. Our first route says take 1010.1. Why is it not in here? Because it's a floating static route, and therefore is it's basically a backup. So the floating static route is not going to show up in here in your static route unless the other one is down. So, and I think that's what they want us to do next. On edge router, administratively disable the exit interface of the primary route. So the primary route was what? A serial 000, I believe it was. Yeah, serial 000. Let's go to interface serial 000. Oops. Shut. Now that it's down, let's trace route from PCA to the web server. PCA. We'll trace route again. Notice this time, last time he went from his default gateway to the 1010.1 and then to the web server. Now he's taking default gateway 1010.5, which is ISP2. And then he makes it to the web server, right? Did the backup work? Did the backup route work? If not, wait, if you will, it did work basically because we took this route because after we shut it down, right? Restore connectivity to the primary route and then trace the route from PC1 or PCA to web server. Verify that the route is restored. So let's restore connectivity. You notice how this is down, right? That route is down basically. So you're saying, okay, this route is down. Let's go this way because it's up. And that's why, because we manually configured it that way. Dynamic routing protocols will do this for you automatically because they always change and they know when something's down, etc. Well, not all the time, but for the most part, that's what dynamic routing protocols are, designed to do. Static routes, they don't scale well. If you got 1,000,000 routes and you got to write down, that's like trying to figure out, that's like writing down ways to get to your friend's house all the time when you could have just used the GPS that automatically updates all the time with Google traffic and stuff like that rather than one route all the time. It's not scalable. So let's bring that interface back up and then take a look at the trace route as well as the router table. So no shut, let's back up. Let's trace the route again. And now last time he took 1010-5. This time, hold up, it's taking the backup route again, I believe. Oh, maybe we gotta wait. We gotta wait till it come back up because look. Well, it's green. Let's see. Let's try it again. There you go. See? It just needed to wait. It was still taking a backup route, so we needed the route to converge basically. Now it took 1010-1. Had me thinking that I did this wrong. Okay. Now let's take a look at the routing table and let's see. Oh, I guess we should have seen what route we had in there. Damn, we should have viewed the routing table. Let's do it anyway. Let's do it. Let's do it. Let's shut him down again. Oops. Shut. Right. Now let's take a look. Do show IP route. Now he says take 1010-5. Right. Now no shut. Right. Back up and let's take a routing table. He still says 1010-5. 1010-5. Right. Now it's back up. 1010-1. See that? All right. So that's a floating static route. This is another example right here. This is just a configuration for it though. To get to that network and that network subnet mask, take this network interface. Take this next hop router, but set the AD to 200 in this case. So below, now let's look at this route administrative distance table, right? We can have a route using EIGRP interior, right? We can have a BGP route, we can have an IGP route, the EIGRP. We can have all these routes, right? Because they all under, right? But our 200 route will be backup. That's like in case all else fails, go ahead and take this route. That's basically what that's doing. So recursive lookups. We're going to go more into this in the next video because I'm going to combine an activity. We're going to combine static routes, default routes, as well as recursive lookups. Basically, you got to look up a route twice because it has to look at the routing table and then resolve it to the next hop IP address. So it's got to look up an address twice before having to send traffic that way. We'll go over that in the next. We'll go more in depth in the next video because I'll have an example to be able to explain that for y'all. You want to pause it, look at this. Or just email me or send me a comment and I can email you the slides if you want this definition. Or just Google it. Leave me alone. I gotta rest. I got stuff to do. Anyways, thank you. If you like this video, please comment, like, subscribe. You don't like this video, comment, like, subscribe to the network.